Hello, my name's Chris Kurzik, and I'm the Principal Engineer at Athabasca Engineering Solutions, AES for short. And what does AES do? Well, first of all, we provide third-party value evaluations. We provide training and certification. We provide equipment re-rating.
Welcome back. We're looking at example 4.2.2 nozzle weld details and weld sizing. And this will be an interesting episode because we will deal with Section 8 Division 1, the first part, and the second part we'll deal with the Code Case 2695 and in particular part 4, which is designed by rules. So let's jump into this one. We have method 1, ASME Section 8 Division 1 as the first part of our presentation, and in that one we're just using the rules of Section 8 Division 1, and the second one is the Code Case 2695 once again, but in particular we're going to focus on the requirements for nozzles. So let's dive into method 1. So we're going to look first of all at the joint categories and review them. One thing you'll find is the Division 1 and Division 2 rules. The joint categories are exactly the same, so there's no issues. So we're going to focus on the weld, the category D connection. We don't have any A's in this case because we have a seamless pipe that we're connecting to, when we're not looking at joint type C because we're not dealing with flanges in this particular example. So I'm going to dive right into this and let's set up our problem. So we're going to do a straight Division 1. We're doing the method 1 design, and the shell material is made of a tough low temperature plate, 570N. Particularly, it's a very common material found in Canada for pressure vessels, and we're going to use a nozzle material to match up the MDMT. It's going to be an SA 350 LF2 Class 1, which is low temperature service, and the component we're looking at is a nozzle to shell. So we've got the thickness shown there. We've also got the nozzle size, the nozzle thickness, and the corrosion allowance all shown. Okay, so let's continue. These are the essential elements that you would need to design your vessel nozzle welds and get your details right. So first of all, we do some preliminary calculations and we have to adjust for the corrosion allowance because we have to use the final corrosion allowance as per the requirements of UG-16. So we make those adjustments and we continue. So I've set this up in such a way that we can easily see what we're doing. There's a minimum requirements for attachment weld openings, and that's the throat thickness, TC, which you see here. So that of course, the weld here is always going to be the same thickness as the material, and this is a full penetration weld, is what is generally what's done. And there's a criteria on your UW-16. It says you take the TS, which is the thickness of the shell, right, and thickness of the nozzle, which is shown here. And then you take the minimum of that, but you need to, or you go ahead and you use the minimum of 19 millimeters. Okay, and so that just makes sure that your weld doesn't get unnecessarily large. We do the calculations, we get 0.375. We continue. down to UW-16, and where TC must have a minimum thickness shown here, okay? And so we determine that to be a quarter of an inch. But then we have to make a correction for the weld size, because that's just the throat, which is shown as this way. But the weld size, we have to divide that by 0.7, or you can say, because it's a equal-sided fillet weld, we're assuming. If you want a more exact one, you would use 0.7071. But in reality, we're going to be, how accurate do we need to be, because we've got 0.357, and then we're going to use our nearest size, and they typically go to the nearest eighth of an inch, or round up to the nearest quarter. So at the end of the day, our fillet size TC would be 3.375 or 10 millimeters. So let's continue on here. So we looked at method 1, and now we're going to look at method 2 using code case 2695. And we're going to continue with that. Method number 2. So let's take a look at some background before we dive into method 2, because there's a few more steps involved here. Alternative rules is very, very specific on the descriptive requirements. So they have a table in addition to the chart. But in our case, when we read the description, this is what we're looking for. We're looking for a weld category D, and it's for attachment nozzles to the main shell, which is what we're doing. And there's a bit of a description there on transitions, but category D is what we're looking at. And so once again, it's the same diagram again. So we're going to be looking at the category D weld. So they have, in summary, they have another table to really get it down packed. I've never really seen, my opinion is that I haven't really seen too much reasoning for table 4.2.1. But I mean, I think it's just to make sure that you consider other cases like intersections, and those kind of things that may not be readily apparent. And so it just makes sure that you understand where you need to go. So let's look at the weld types, which is section 4.2.3, and the version I was looking at, which is the 2019. And this is where we talk about the types of joints, and this is all set up for a selection table. In this case, it's a corner joint with full penetration welds, and with or without cover fillet welds. So this is the one we're looking at for our weld design. Next, we're going to look at, because we're looking at a category D weld, there's a number of rules that you have to go through. It's more like a checklist, okay? So we look at the ones that we're most interested in, and in this case, we're looking at A there, and we're looking at a full penetration corner joint at a nozzle neck or fillet welds, or both. The other ones, they're not quite a match. So the category we would follow is an A3. So let's continue a little bit further here. So then we go to B, and it says acceptable category welds in the following tables. So it's leading us to go to table 4.2.10, and because they give by rules, because part 4 is all about following the rules, they allow you to they give you standard designs. Now, question comes, well, can I just use design by analysis like part 5 for the code case, that we're looking at, which is that 2695? And the answer is no. You can only use part 4 rules. So let's continue here. So another rule is nozzle welds without reinforcement. There's rules for other ones, but let's take a look at that. It says nozzle necks abutting a vessel wall with or without a reinforcement element shall be attached by a full penetration groove weld. And I mean, I wouldn't know when I wouldn't put a full penetration groove weld, but they're just reminding you. Backing strips shall be used with welds deposited only from one side, or a complete joint penetration cannot be verified when it cannot be verified by visual inspection. Backing strips, when used, shall be removed after welding. And permissible types of welds are shown in table 4.2.10, details 1, 2, and 7. Okay, so that once again, this section 4.2.5.5, it leads you back to table 4.2.10 for the type 7 type of configuration we're looking at, which we talked about earlier. So it's one thing I like about alternative rules, you can go a couple different ways and it ends up in the same spot, as you should. So we'll continue. So finally, at last, we're at table 4.2.10. You can see that there's quite a few more steps involved, and they add a lot more. There's a lot more specific rules and alternative rules that you need to be aware of. And a future video, we may do one for the repad, and there's special requirements for the reinforcing pad. So in this case, we've selected because we've got a joint type 4 and a joint category D, we're basically following the rules shown in here in detail 4 in table 4.2.10. And the basic rules is they have a minimum thickness requirement for that fillet weld, okay? And they have a special requirement for the radius down here. And that has a lot to do with fatigue. We'll get more into that later. We'll compare, study this R1 a little bit closer, okay? So let's continue. So there's some specific rules for the maximum R1, and I wish they would put that in the previous tables, but they don't. And so just to be aware, when they do fatigue analysis, it's also important to limit the maximum. And in the example, in the ASME PTB-4 example, they have a maximum of 1/2 of the shell thickness. And I believe it's because of this criterion. When they do fatigue analysis, they want to make sure that when they put the model in, that everything, those kind of things are controlled. So that's where that large diameter comes from. So we're going to continue on. So now, after all these steps, we're finally at the point where we can do our calculation, right? So we've got our joint type 7 and D, and you've seen the diagram. So we're going to do the calculation. So we go to the section 4.2.4 requirements. We end up calculating a 1/4 inch minimum weld size based upon these criterion, okay, which is shown in the previous chart. And then because this is the throat area, we have to convert it to a weld size, so we jump it up, and lo and behold, at the end of the day, when we go to the nearest size, we have exactly the same answer as the section 1 calculation. Okay, so then we go on and we're going to go and look at this R1. Remember, R1 was that inside radius. So that table gives the minimum requirement. So they say you can get as small as an 1/8 of an inch is as small a radius as you're allowed to get. And because of that rule that I showed you in 5.10, 10-1E, recommending that it's like half the diameter, or half the thickness, and then that would be your final answer for that. So let's make some conclusions from what we've learned about doing these welding sizes, and we had a look at Division 2 as well, to the alternative rules. The Section 8.1 does not provide the requirements for the inside quarter radius R1. If you look at, for example, at UW-16.1D, which is the one we are looking at in today's presentation, there's no specific requirement as is shown in Division 2, and that has to do with regards to doing a more detailed analysis like fatigue analysis. And Section 8, Division 1, but UG 76 B and C do indicate that exposed inside edges shall be rounded or chamfered. So, they still want you to go and remove those, but they're not being specific. Now, with Division 2, they have minimum and maximum requirements. And when we did the analysis, we found that the throat thickness design of that fillet weld was the same for both methods.
I hope that you found this presentation useful and valuable to you. This was provided by Athabasca Engineering Solutions. We'd love to hear your feedback and your thoughts on further videos. And we'd love to hear from you. Maybe we can do some business. Please subscribe to our channel so you don't miss a thing. Take care for now.